Hello, everyone. Welcome to today's Lunch and Learn here at Job City. As you guys know, every month we like to showcase a new topic, something that you guys bring to us to show your expertise on something specific. Today, Caio Cesar Bosco is presenting to us this very interesting topic. If you guys know anything about blockchain, you might like it a lot. And if you are interested in it, this is the perfect place to maybe learn a little bit more. We're going to talk about building a smart contract on Solana blockchain. Is that right, Caio? I think this topic is very interesting. Please take it away.
Yes, exactly. Uh, exactly. Just a minute. Okay. Exactly. Welcome everyone to this Let's Learn. I would like to express my gratitude for Job City to offers me this space, this time to sharing a little bit of knowledge of this amazing subject that is blockchain. So uh, I would like to start introducing basic concepts for those that don't know yet what is a blockchain. So blockchain technologies get notorious attention the last years due mainly Bitcoin or even Ethereum. So meanwhile, most people get interest in the subject looking a way to get profitable short-term access trading. Few people really understand how much this technology will going to impact the consumption of the digital projects the digital products on the next years. So I would like to ask everyone to trust me on those things I will tell. I'm not explaining why, but we need to trust this at this moment. That blockchain technologies we're gonna bring a way for decentralized database and decentralized systems enable is database addition and data sharing between untrustworthy parties is going to be easy. So in the showed picture, we can thinking on the centralized graph, not as a server, because we know currently on our days, the the servers are spread around the world in a distributed topology. But here we can think each node of this graph as an entity. So when we look on the right side for the right picture, it's impossible to thinking on decentralized entities sharing same data, same system without thinking on blockchain. So the most common example is the banks. We can think in here the regular persons, the customers, the bank customers, uh, they need to trust an entity that's the regular bank. The bank, on the other hand, the regular bank needs to trust other greater bank, that's the central bank. Central bank, it's a works for government, and so we have a chain of trust that are blocking the technology for the next years to creating great stuffs. So in this new world, we can see on the right picture as an example. For instance, Bitcoin. It's very similar as Bitcoin or even other blockchain, but each person will run. Not each person, but each node, each validator, each miner, each entity that would like to run the entirely database and provide a way to um, authentify its data, to audit its data, it will be possible. So again, blockchain technologies enable easily auditability, meanwhile the privacy of the user. So blockchain technologies enable untrustworthy companies share same database without compromising data integrity. So the key word here is sharing data between untrustworthy parties. So today we are living under Web 2.0 internet era. In this era, each system is centralized. We can thinking about the banks, we can think about Facebook, about Google, and things like that. And Web 3.0, we're going to break this model, promoting decentralized infrastructure based, of course, on blockchain technology. Decentralized infrastructure means different entities running their own node and try to reach consensus under the blockchain state. So, as I said, users are able to not trust in a single entity anymore, because centralized systems offer full transparency and promotes lacks of confidence between entities. And confidence, it's other keyword for the new word. So hypothetically, it's just hypothesis. I'm not saying that happens or not. I don't know. But we can think in regular banks, for instance, cheating data for customers or even for government. And for sure, the opposite can help as well. Facebook, other situation. I'm not saying that's true. It's just a hypothesis, just to bring in some, some context, some motivation for blockchain. So we can thinking on Facebook or even other Web 2.0 social media that they are able to fake likes. They are able to fake like numbers and could unfairly favor some ad or even weakening democracy process, favoring some selected politics option, for instance. So we need to keep in mind that the next generation of web apps are brings people will interact with internet knowing that things are real, that things are trusted. So it will promote a good way to go against bad content and malicious users. Of course, it will gonna protect digital content creation. So people that create digital content will be receiving rewards for it, and they can prove that the content is in fact yours from there. And even democratize the governance of platform rules. So no more fake news, fake profiles, piracy, and dictatorial algorithms. Okay, but what is a smart contract? When we think about Bitcoin, we can see that, sorry, just a minute. Okay, I believe everything's okay. Let me open it again. I wish everyone is listening well. So let me explain what a smart contract is. Basically, we can thinking on Bitcoin. Okay, so Bitcoin just provides one feature under their blockchain blockchain network, and this feature is trading coins. Just it. We don't have an intermediate bank. We have a computer code that performs the transactions automatically for users. But what if we would like to using the blockchain for anything we want? So here is the smart contract concept. The smart contract concept was introduced by Ethereum network, and basically it provides a platform for developers create their own business logic on top of blockchain network. So here we have a simple example showing Bob's and John. Bob wants to sell his house and John wants to buy a house. So Bob, I don't know, some company would can create a smart contract on some blockchain networks such as Ethereum or even Solana, as we will see it today, and create there a logic that when a person would like to sell his house, when this person meets all the requirements such as publishing the land deed documents, digitalize it, and things like that. And if someone would like to buy it and transfer the money, no any intermediate entity will take this money because it will gonna be transferred smartly using the smart contract on the network, and even it's safe and trust because it will gonna be performatic automatically. I hope everyone are enjoying what I'm saying. I wish I'm not being not boring talking. So let's see about what Solana is. I'm gonna first of all open here the Solana website. So what Solana really brings for users? What's the difference? What Solana brings then different than Ethereum? Basically, Solana provides a fast network. It's quite performatic. Performs lots and lots of transactions per second. It's the most fast blockchain networks. Of course, it brings some lacks of security, but that's not on this in the scope of this presentation. That's out of scope. Other thing is Solana is cheap compared with Ethereum, for instance. Other lack of security as well, but again, out of scope. So basically, those are the main characteristics that Solana has, being fast and be cheap, okay? And it starts to get some famous the last months. Okay. Just a minute. I believe everything's okay. So, no. Let me return for the presentation. Here. So, first of all, I'd like to introduce some Solana terms here. First, we have a Solana cluster. We can see the Solana cluster as a lot of computers that don't know each other. But people that are using the chain can see those computers as independently computers. And they working together sometimes, or even sometimes going against each other. So this is a cluster, blockchain cluster. And there's where users will submit their programs or even smart contracts. Program term and smart contract is the same thing under Solana universe. So every time a user would like to preserve an immutable record of events and time with programmatic interpretation of those events, they need to create a smart contract under the Solana cluster or even Solana blockchain. So what is a transaction? Transaction, it's a program execution. Sorry, a smart contract begins with a transaction being executed. These transactions must be submitted to the cluster, and the Solana runtime, the cluster, is going to execute this transaction, processing each instruction contained there in order and atomically. So what is instruction? Instruction is the small piece It's the smallest unit of execution logic over a smart contract. An instruction specify, sorry, no, that's not important. Okay, of course, an instruction needs to tell which program they are executing, things like that. And as I said, in a transaction could contains more than one instruction. Let me say, okay, what's the account? When our smart contract needs to persist data under the chain, the infrastructure need to be paid. So accounts is used to persist the data. So each piece of data that will be persisted must be attached with some Solana account. So this account is gonna be paid for the transactions. And what more? Oh yeah, and the account will have metadata to tells which account is allowed to access the data and how. What a program is a piece of code that interprets instructions. Okay, cross-program invocation. That's something that brings very powerful, a great power for blockchain network, because basically you can create some smart contract and publish it as a very similar as a library. So other persons can call your smart contract, and you can be paid for it, for instance. And so that's it. Smart contracts can call each other independently without any problem. And what's a client? It's a computer program that accesses Solana servers using remote program calls, RPC. Okay, what more? Oh yeah, finishing talking. Let's code. Linus Torvalds says, talking ship, show me the code. So I'm gonna show it. Oh yeah, I forgot. If you try to create to developing under Solana blockchain, it's something I'm considering very low level language programming. So lots of details, lot of concepts, and of course this brings more powerful for your flexible design if you would like to create something under Solana. But every time we have some low level abstraction, we always will have a framework. That's not surprising for us with programmers. So here in this talking, I'm gonna use the Anchor framework, and it's a framework that provides moving straightforward way to building Solana programs or Solana smart contracts. They're the same, programs and smart contracts. So okay, let's go here for our first basic example. Every time you create, of course, you need to doing some little setup. You need to perform some setup to install the Anchor framework, the Solana, and things like that. I'm not getting into details. Okay, if you would like to know exactly how it works, go under Project Ethereum GitHub.io. Let me. I can share this address. I don't know. Okay, I'll try to available this website address for anyone that would like are interested on access it. Just a little bit. Okay. Sorry. I've done a little pace here to know if everything's okay. Um, Let me see where I stopped. Okay, as I said, we have the Anchor framework, and if you would like to know how you how you set up your environment, go here under Project Ethereum webpage, and you have all the instructions. Okay, so I will jump it, and let's go for our first example. So every time you create an Anchor project, you will have this directory structure. Okay. So the first thing we can see here is, let me do this. Okay. And here we have a program or even a smart contract. Okay. We are defining here a smart contract, call it basic zero. And this smart contract do anything. It has just an instruction, and this instruction is called initialize it. There's some metadata here. I'm not explain because do not care at this moment. And here we have a serial a structure to use it for serialize. Okay, to serialize the data that we're gonna that a client we're gonna pass to the Solana cluster. Okay, so I will show. Other thing here is our program ID. It's kind of an identifier of your program. So let's build it first of all. Build our project. We just execute Anchor build command. And there it is. We have properly built it, our smart contract. So when we go here on our target directory that has all the objects that we just create with the build process, we can see here, there. We can see here all these smart contract started to being serialized, in this JSON. So it describes our instructions, what parameters it needs to being executed, the name of our smart contract, and that's it. So when we would like to run this smart contract, first of all, we need to execute Solana network node. We are doing it in a local testnet. If we would like to put it under Solana main chain, there's a lot other ways to do it. We are just doing on our local net. To doing so, I'm gonna run Solana test validator. So there it is. It's a Solana node running on my local environment, and of course can validate and interpret instructions of the smart contracts we are creating. So what more is important? When we go here under this Anchor descriptor file, we can see here some things. First of all, we are working with local net, as I said, local environment. The other thing is we have here the address, the ID of our program, as I properly showed here. Oh, sorry. Okay. Other thing, oh, that's not important. It's the script for doing tasks. But here is the other thing important. You will see that in blockchain, for instance, each piece of the chain is public. If of course we are working under a public blockchain, but not any people can provide. Not any people can transact in. Let me try to explain. For instance, we are creating this smart contract, but not any people are allowed to to run initialized instruction. Okay, so we have a wallet. Wallet is a very common concept on blockchain. Is where we're gonna hold our private and public key. The private key is yours. We never share with anyone. The public key is as our address. So every person can take our address. Very similar as the credit card. You have the number of your credit card that you can put in a lot of websites, but the security code you never share with anyone, right? It's very similar. So, okay. So here is an instruction. Let me take here. I forgot here. There's instruction for create a new key pair. Okay, we need to create first of all a key pair, a private and public key for us. I'm gonna. Okay, the command line are saying me that I need to force the flag because I already have a Solana keychain, a Solana key pair. So I'm not gonna do it because the thing's gonna messing up. But in your machine, you can run this command without any problem, and you have a Solana key pair. Okay. So in our description file, I am pointing for my wallet, so the program can be run without any problem. Okay. What more? Oh yeah. Let's deploy our smart contract. We just built it, right? So here are our nodes, our validator node running, and let's deploy our program. To do it, let's just execute anchor by command. Let's see. Right, amazing. It has been deployed. And here is our program ID. Amazing. So still we have, at this moment, we have on our local environment a smart contract called basic 0. Okay, our chain already, our local chain already understand this is a smart contract. So we have here what we need to interact with this smart contract. We need a client. And of course, we have a JavaScript client, the best way to do it. So Anchor even provides a node package to interact as a client. Okay. So here we have some concepts. The first one is the provider. Remember, I said that we have the private and public key. The set providers provides a way to deal with those operations, such as signing a transaction and verifying if the people that are signing is the really owner of the program or not. So it abstracts a lot of cryptography operations for us. Here we need to read the serialization methods our smart contract have, such as some metadata, such as the address, the instructions it has. Here we are telling the program ID of our smart contract that we'd like to execute. And that's it. Here we're just doing a remote process call for our initialized instruction over our basic 0 smart contract. Let's run it. Oh, yeah, that's an important thing. we need to say for anchor client on JavaScript where our keys are. To do it so, we need to here. We need to do it. We need to set environment variable called anchor wallet that points for our Solana keeper. Okay, I already do it, but you need to do. You need to set this environment variable, otherwise the things will not work as properly. So let's now run our client. Boom. So as I said, this smart contract do anything. Yeah, it's a bypass program, but we can see how we can deploy a smart contract. I show you how things works, and I would like to listen if I have more time to showing one more example, more interesting one. Amazing. So let me show other example, a more excited one than this one that is very basic. Let's dive now on this one. Okay, so now we have we declare here a smart contract called basic2. We attach a program ID for it, identification for our smart contract. Now we have two instructions declared inside of our smart contract. This smart contract just basically it's a counter, and this counter we're gonna persist the data each time we call the instruction increment. Okay, so the first instruction we're gonna create a counter. This counter, of course, will start with a new value, a zero value, and every time our client calls increment instruction, the counter is going to be incremented. Okay, so let's read it a little bit with more carefully to understand the things. So here, as I said, we have the serialization of our smart contract. But remember when I said on the slides here that everything inside Solana, every data that need to be persisted is needed to be an account attached with it, because this account needs to pay for holding the persisted data. Okay, so here what we have the create instruction. We are telling that we need an account attached for our counter. Okay, we are telling here that this account must be initialized. We are telling that the payer of any operation or any instruction executed on our smart contract must be paid for user, and this is the user. Okay, here I'm not entering these details. It's about memory allocation, and we even saying that okay, our user can be muted. Is muted. Mutable. It means that the user can be changed. The payer for the smart contract can be changed in the future. Okay. What more? Create authority. Let me see what it is. No. Okay, here we are talking about authority. Okay, now we have here the increment instruction. Basically here we are telling that our counter, it's a data that can be mutable. Of course, we are going to increment it. We are saying the account that we will hold it, as we said here. And we are saying that this contract has one authoring. So it's one people that really create the counter, and possible is the one that's allowed to increment it. And remember about the key pair I said before. So here we have the signer of this operation. So authority declared here must sign the operation to increment, and the other one, this user here must sign to create the smart contract. Okay, so our counter basically consists of account number, integer value, and an authority, someone that is allowed to increment it. Okay, so basically here, that's what we are passing on creation. We are telling who is the authority to increment this counter. So in the beginning, we are just setting these variables. We are creating a counter with 0 value. And every time we call increment method, increment instruction, we are taking the counter as a mutable variable and increment it. Amazing. So again, some things here. Let's open this file. I'm telling that I'm gonna run this smart contract on local net environment. I'm telling where the platform can look for my key pairs, like private and public key. We are telling here the smart contract program ID here. And we can forget about the test scripts. What more? Okay, here we have finally a client that we will gonna call this smart contract. Oh yeah, let's first of all, let's build. I'm finishing, just a minute. Just one more minute. I'm gonna finish. Okay, let's build our smart contract. Let's see. Okay, and now we need to deploy it. Our validator node are still running, so we don't need to run it again. Anchor deploy. And boom. Our basic 2 smart contract has been deployed on our local net blockchain. Here's the program ID. And now let's do a call, a client call for our counter smart contract. Again, same stuffs. Here we we are using the Anchor node package and other stuffs here. The provider, as I said, that will deal with the cryptography operations and things like that. Let's see the smart contract serialized here. Amazing. We can see the smart contract, the instructions it has, creating. It has increment instruction, and even it argument it will need to pass to be executed. Amazing. And any other information that is needed here. The address, okay. And now, okay, we take this information. We take here the program ID. And now it's something very important. We create a new key pair for our counter program. Remember about the account that we need to pay for the counter. That we're going to be allowed to increment, and that's our account. We create a new key pair. And here we create the smart contract, and the one that is that's going to pay for it, it's us. It's us that we are deploying. So here is the public key of the provider, me. Um, the counter, we're going to hold the public key of this public key we just created. We can forgive about the program ID at this moment. And here we call the remote process. We create the smart contract. We can check that it's in fact has been created. And here we can increment our counter, okay? Passing the counter address, the provider public key here, just to identify, because under the hood, we're going to have this signing process with the private key that is under our machine, and the provider will deal for us. And let's run it. And boom. So it checks if have done the asserts for us that it's the counter really has been increased. Okay. And I'll stop here. Sorry if I take more time than I was allowed to. And I really hope you enjoyed this section. Thanks very much.
All right. Thank you, Caio, for showing us at least a brief introduction into Solana, and for some of us, even how the blockchain works inside this, the smart contracts and all of this. I'd like to know, first of all, if anyone in chat has any questions, post them now so that we can pass them along. Meanwhile, Caio, I'd like to know, you said Solana is kind of being a new option to build all of this aside of using Ethereum. You can, instead of using Ethereum, you can use Solana for building your contracts, etc., etc. Is there any reason why we should not use Solana if speed is not what we want? Because from what I can see, Solana is much faster than Ethereum. It uses a different type of proof. It uses proof of stake, I understand. Is there any reason not to go Solana, you think, if we are going to build any sort of blockchain system?
Yes. First of all, it's a very generic question. Of course, each chain has the pros and cons. As I said, what Solana brings interest compared with Ethereum is being fast and being cheapest compared with Ethereum. Okay, that's the main characteristic of Solana that brings attention of developers, brings attention of companies. Solana has a lot of things that is different than Ethereum, but under the hood. How can I explain? For instance, yes, Solana works as a following proof of stake algorithm, but it's more than that, because we can see the consensus algorithm that Solana uses. It's very different than any other thing that I already see. It calls proof of history, and it enables transactions being pushed for the chain asynchronously without validate it at this in the moment. So I don't know. Each chain will have their pros and cons. I don't know very well about Ethereum to say what Ethereum is not good compared with Solana. Okay, But the main thing is Solana is cheap, Solana is fast. That's my opinion. Of course, we can have a lot of other things.
All right. Thank you, Caio. I think, as we seem to be transitioning in this between Web 2.0 and Web 3.0. It is very interesting to see how things develop. So it's good to see that there are more options out there as well. As you presented, Solana is a good option if you want to at least start building smart contracts and try this out. Your presentation was fantastic to show us the way of doing this. I have one question in chat, and it's, is it expensive to keep, it says one account storage, 1 giga of data. Maybe you can explain, try to approach what the question is trying to ask from you. Is what load does it have in your in the account when it comes to space storage?
I see. Yeah, that's a question I would confess I don't have the answer, because I never deploy it in real, some smart contract for Solana network, sorry. But something I really can say at this moment, it will depend about the token value on the market, because all chain tokens, we can see Bitcoin, we can see, no, stop, let's not think on Bitcoin because it's very different. Let's thinking all the proof of stake chains tokens. Most kind of them is using some kind of stable coins, some mechanisms to swap those coins with some stable coin as a dollar and things like that. So the value of it, of course, will depends of the value of the token. That's something very unstable at this moment. Something that we really need to keep in mind is blockchain. It's a new technology needed to it's just under the childhood, but however, something that we need to pay what is the future. Everything is going to be played on the chain on the future. As we run some services today on a cloud environment, we will run a lot of major applications on chain, because it will bring trust, as I said, and trust is a key word for the new era of the internet.
All right, thank you very much. I don't see any further questions in chat, but I do want to thank you for everything that you presented to us today. And I'm sure that if anybody else has any question about it, if they are seeing us later on a replay on our live stream on YouTube, they'll probably reach out to you. It's a very interesting topic. Thank you very much, Caio. And thank you very much to everybody here watching live or watching afterwards. We hope to see you in the next Lunch and Learn as well. And if you have any topic that you'd like to present to us, anything that you are interested in sharing with us, let us know. Reach out to either me or Simona or Yana, and we'll make it happen. Until then, until our next Lunch and Learn, I'm Sebastian. Thank you, Caio. And thank you, Simon.
Thanks very much.
Background. We'll see you next time.
Bye. See you.